Utilization is the wise use of available bandwidth to achieve specific goals. Efficiency can be achieved by multiplexing. Privacy and anti-jamming can be achieved by spreading. Is the set of techniques that allows the simultaneous transmission of multiple signals across a single data link. Today's technology includes high bandwidth media such as optical fiber and terrestrial and satellite microwave. Each has a bandwidth far in excess of that needed for the average transmission signal. Bandwidth of a link is greater than the bandwidth needs of the devices connected to it. The bandwidth is wasted. An efficient system maximizes the utilization of all resources. Bandwidth is one of the most precious resources we have in data communication. In a multiplex system, N lines share the bandwidth of one link. There are three basic multiplexing techniques: frequency division multiplexing (FDM), wavelength division multiplexing (WDM), and time division multiplexing (TDM). The first two are techniques designed for analog signals, the third for digital signals. Frequency division multiplexing (FDM), an analog technique that can be applied when the bandwidth of a link in Hz is greater than the combined bandwidth of the signals to be transmitted.
Division multiplexing, or known as WDM. It is designed to use the high rate capability of fiber optics cable. WDM is conceptually as the same as FDM, except that the multiplexing and demultiplexing involve optic signals transmitted through fiber optic channels. The idea is same. We are combining different signals of different frequency. The difference is that frequencies are very high. Though the WDM's technology is very complex, the basic idea is very simple. We want to combine multiple lights source into the one signal light at the multiplexer and do the reverse at the multiplexer. The combining and splitting of light source are easily handled by a prism.
Time division multiplexing (TDM), a digital multiplexing technique for combining several low-rate channels into one high-rate one. One problem with TDM is how to handle a disparity in the input data rates. In all our discussions so far, we assume that the data rates of all input lines were the same. If the data rates are not the same, three strategies or a combination of them can be used. We call these three strategies multi-level multiplexing, multiple slot allocation, and pulse stuffing. Multiplexing, a technique used when the data rate of an input line is multiple of others. Multiple slot allocation, sometimes it is more efficient to allot more than one slot in a frame to a single input line. Pulse stuffing, sometimes the bit rate of sources are not multiplied integers of each other. Therefore, neither of the above two techniques can be applied. The solution is to make the highest input data rate the dominant rate and then add dummy bits to the input lines with lower rates. This will increase their rate. This technique is called pulse stuffing, bit padding, or bit stuffing.
Spectrum multiplexing combines signals from several sources to achieve bandwidth efficient. The available bandwidth of a link is divided between the sources. In spectrum activate, we also combine signal from different sources to fit into a larger bandwidth. But our goals are somewhere different. It is designed to be used in wireless applications, LANs, and WANs. In the type of application, we have some concern that our with bandwidth efficient. In wireless application, all stations use air or vacuum. As the medium for communication, station must be able to share this medium without interception by an eavesdropper and without being subject to jamming from a malicious intruder in military operation. For examples, Speed spectrum NIS-FHSS. The FHSS technique uses n different carrier frequencies that are modulated by the source signal. Speed spectrum. The DSSS technique also expands the bandwidth, the original signal, but the process is different. Thanks.
transmission signal. If the bandwidth of a link is greater than the bandwidth needs to
Are worth the same. However, if data rates are not the same,
This median to without interception by EV carrier frequency that are modulated by the source original. Larger bandwidth. But our goals are somewhere different. Spectrum is designed to